Hello guys. Now I'm going to explain artificial neural network. This is called supervised machine learning method, also called deep learning method, which is under machine learning. And under artificial network. So if this is the biggest set, and under this biggest set, this subset is called machine learning. And further subset is called deep learning. The smallest one is the deep learning, and the middle one is machine learning, and biggest set is artificial intelligence. So basically, the deep learning is also a subset of artificial intelligence, or also a machine learning method. So whatever, artificial neural network is a deep learning method because it is very complex method and it is very difficult to understand often. So today I shall try to make it very easy. Also, it is called supervised machine learning. Why? Supervised machine learning means when you have, say, you have two set of variables. One is dependent and others are independent variables. For any model, for example, any regression model. When you don't have any dependent variable in your data, that is called unsupervised machine learning. But when you have dependent variable into the data in your data, that is called supervised machine learning method. This is very simple. However, why they are called supervised and unsupervised, that depends, that basically connected with example, like a specific example. For example, if you want to identify, detect, or if you want to detect faulty products in any production. So fault products or fault items, to identify them, one manual method is like manually by labor, or people or men have to identify one by one. And that identification needs some supervision. And that's why those kind of things called supervised machine learning, because when you have identified manually for every item which products are defected, which products are not defected, then basically you have label, you have Y variables. Okay, you have Y variable, because if your independent variables are the determinants or factors affecting the defect, which is number of machines, type of machines, age of the machines, or something like that. So whatever, when you detect the products, faulty products, manual way, that is called supervised machine learning, because you are supervising that detection. But when you don't do that, when you don't detect by that way, rather you are making, you're using the machine basically to detect that. So machine, what does it do? Machine takes the picture of every item, and that picture was sent, that pictures are sent to the computer, and computer basically detect the faulty item based on the characteristic of that item and also the machine. So that is called unsupervised machine learning, because that is not manual job. Nobody is supervising the machines to do that. Machine automatically is doing that. So that's why in that case, there is no Y label. There is no Y label, because manually nobody has put the every item, what is the label means whether it is defected or not. Machine, after doing the analysis based on all the other characteristics, then it identify which are defected, which are not defected. That's what it's called unsupervised machine learning. So whatever, when you see artificial neural network, most of the cases, whether it is YouTube or any internet source or even book, the people usually explain this thing by this way, like this is called input node, and the input node making a hidden node, and that hidden node is making the output node. The hidden node can be many. Hidden node can be many. So all hidden node can lead to the output node. So this is input node. This is hidden layer, also called hidden layer. All are hidden layer. And this is output, the outcome. Output node or output layer also called. Whatever. So this is the way people explain the artificial neural network. Because these are also called neurons. All the node also called neurons, like human body. So one neurons giving signal to other neurons. So the input neurons giving signal to the intermediate or hidden neurons. These are hidden neurons. These all are hidden neurons. The hidden neurons giving signal to the output neuron, the final neurons. This is the stopping place. So this is the simple explanation of artificial neural network. But how this explanation will give you understanding how artificial neural network works in data, basically, in explaining the data. So first of all, what is the objective of doing artificial neural network? Artificial neural network is very powerful method to make any prediction. So this is a machine learning method mostly used for prediction. And this is called a non-parametric method, because simple OLS regression also can do prediction, but those are parametric method. Parametric means you can make relationship between Y and X. How much X increase, for that how much Y increase. You can make the relationship parameter. But in the case of artificial network, you cannot have such a parameter. You cannot show that for 1 unit increase in X, how much Y increases. The artificial neural network is called non-parametric method, and but it is very much powerful method to make prediction. Sometimes it can give 95% accuracy in prediction. So that's why it is a very powerful and popular method in business area. For example, any big shopping chain, say for example, Tesco in the UK, how many chicken or how many bags of rice they will put in the shelves in a specific day. That specific day can be weekend, can be rainy day, or can be hot day. And based on that characteristics, they can decide exactly how many chickens or how many bags of rices they will put in that specific day. Because the predicted amount is very important. If it is higher than actual sale, they will have problem, and because they'll have more inventory. If the amount of amount of chicken or number of bags of rice they put in the shelf, which is lower than the actual demand in that day, that will also make the loss. So they need as much as accurate amount. That means actual and predicted should be as close as possible. So artificial neural network can give that prediction, better prediction, very accurate prediction. And how does it work? So let's give an example from the economics field, which is very simple thing to understand. So for example, you are a manager of the company, or you are a business analyst, or you are an economist, whatever. You want to make the prediction of profit of the company, profit, based on the quantity sale. So profit is a function of quantity sale. So we know that from the economic theory, quantity sale and profit is a concave shape. Okay, concave shape. This is a concave shape function. That means initially profit will increase if you increase the quantity sale. After some point, it will be maximum, and then after that, if you further increase the quantity sale, profit will be lower rather than will be increasing. So this is inverse U shape or concave shape. So, but the issue is how much good prediction we can have into this data point, because say this is called train data. So this data, that data will be used to train the model, and then we'll have to do prediction out of sample when the future sample will come. So for example, we will be predicting the current or past quantity sale. Given the past quantity sale, we'll train the model to get the predicted profit, and then future quantity sale. So for example, if I want to target a specific amount of quantity sale in the future time, and how much profit I can get in the future time. So that is the prediction needed basically. That time, the future time, we need the prediction. Beforehand prediction is needed so that we can, the business, the company can act accordingly. If you make a simple linear regression, straight line, the function is linear. Also linear regression means linear in parameters, but also it is also linear in variables. So in that case, in the case of linear line, straight line like this, you cannot get better prediction definitely because it cannot fit the data well. In that case, you have to use a non-linear function, but it's still called linear regression because it is linear in parameters again. But it is better fitting the model, you know. It can predict better when you take the non-linear format, non-linear function of the data, the relationship between profit and quantity side. Now, if you use some other form of machine learning method, also called the regression tree, that is also a non-parametric method. I don't want to explain what is regression tree at this moment, but you can, I can just simply say that the profit here for every bin, every say every range of X, like quantity sale, you can make just the average of profit. So by that way, you can make the predicted profit. So when you take very smaller, very smaller range or bins, then basically you will get as close predicted value as to the actual value. So predicted value and actual value will be exactly same if you take the bins very smaller, you know. So that way, basically, you are making very good prediction into the trained data, but actually that is making bias. In future data, that will not give good prediction in that way, because in future is uncertain. So in the future data, because of this high level of prediction, that means the predicted value and actual value is exactly the same. In that case, it is making bias. So bias to the actual value. So then bias and precision is the trade-off issue. When you have high bias, that means your precision is not good. So in the future, the prediction will not be good, though it is very close, very close. That kind of close is making bias in future data. Basically, in future prediction, it will make bias. So this prediction needs some sort of discrepancy between actual and predicted value. If your predicted value is exactly the same as the actual value, then basically future prediction will be a problem. So in that case, for example, now you have some sort of different kind of shape, some more curvilinear, like this sort of curvilinear into the data. Then in that case, will linear regression with non-linear or quadratic function make good prediction? No, the linear regression will not also work. The linear regression in this format will not work definitely. And regression tree kind of other machine learning method will also not give good prediction. But artificial neural network can give good prediction here. This artificial neural network is not like a regression tree. It's not just like the actual point and predicted point will be same. This artificial neural network will make some sort of curvilinear with some sort of smoothness. It is not like that, not like that, not that. It is some sort of smooth. Say smoothness is there. Every bend, there is some smoothness. So that makes some realistic prediction. not very close to the, it is very close compared to linear regression, but it is not as light as same to the regression tree, because regression tree has the danger that it can bring exactly same predicted value and actual value can be same. So nonlinear regression cannot capture some sort of more curvilinear scenario, which an artificial neural network can do. But regression tree can capture this curvilinear, but that makes very close. So artificial neural network basically in between. It is in between linear regression and regression tree. Okay, in between. This regression tree is too much close, and linear regression is too much far, and artificial neural network is in between. It is not too much close and not too much far. So that's how it can give better prediction in the future. Like that, if we plot two figures together, like this figure is for linear regression model, like quadratic function, and this black line is for artificial neural network. Now, how does it work with those kind of picture? But this picture is basically slightly different way, but it is giving you the better understanding about artificial neural network. So for example, you have the quantity cell first. This quantity cell is called input node, or called also called neuron. Every node is neuron, but that is input node, quantity cell. Now from the input node, for every level of quantity cell, you are putting signal to the intermediate node, which is called hidden layer. That is also called intermediate predicted profit here. So how did you do? So you make a linear function. So linear function means based on quantity cell X, you are making a Y variable, which is Z1. The Y is not available in the data, and you cannot estimate Z in this moment, but think now that there is a Z, and that predicted line is like that, alpha 1, and the slope is beta 1. Here, it gives another signal to another hidden layer. Okay, so here also it makes another linear regression. In that case, it is Z2. In that case, this might be like that. In that case, the vertical intercept might be a negative, which is alpha 2, and the slope is beta 2. Slope can be positive, but that is Z2. Okay. When it goes to the intermediate layer, like here, from this input layer gives a signal, this kind of a straight line. In the intermediate layer or hidden layer, that straight line, it makes some sort of smoothness, curvilinear, like by converting into log format and exponential. So it takes Z1, like here, Z1, it takes power of exponential e power Z, and plus 1 plus exponential power Z, and it converts to the log, and which is a function of which and dependent variable is y1. Again, this y1 is not available into the data, but hypothetically, it creates like this kind of shape, or even we can show it here. Hypothetically, it can be like Z1 instead of Z1, it is like y1. So this straight line converted like that way, some sort of curved, a smooth line, but not a straight line. And here also, similar way, it convert like this linear line into a curved way. So that line will be like that. That line will be also be like similar way. It will be some sort of smooth upward, but not a straight line. Then in the final layer, what is happening? Final layer, it giving the weight to both y1 and y2. Tau 1 is the weight, and tau 2 is the weight for the y2. So that two line is going to the final layer, y hat, to produce the y hat. Y hat is the final outcome, which is basically nothing. Y11, which is the weighted amount of y1, and y2 is the weighted amount of y2. So it taking the addition and then plus any error it has between these two addition. Within that, it makes the predicted value of y. So how does it work? We can understand better if we go Desmos. But before going Desmos, I can summarize. We can combine all the parameters into one function like y hat. So what is the y hat? Y hat is the weighted average of y11. So this is the y11. And y1 takes z1 exponential power of z, which is z1 is means alpha 1 plus beta 1 x. And the another part of y hat is the weighted average, which is weight is the tau 2, and the average of y22. Y22 is the log of 1 plus e power alpha 2 plus beta 2. So alpha 2 plus beta 2 x is basically z2 or z2, and that makes y22. And that is B, which is making any correction. And how it makes the correction is understood better in Desmos. So that is basically y hat. Now, so there are plenty of parameters. Tau 1 is one parameter, alpha 1, beta 1, tau 2, alpha 2, beta 2, and B. So there are plenty of parameters, but no parameters is showing relationship between y and x, like profit and input sale. There is no relationship parameter. These parameters are all part of the whole process. So that's why it is not called parametric method. It is still non-parametric because of not having any parameter to show relationship between y and x. But we have y hat now. So now y and y hat, you make a MS. It is also called mean squared error. So you choose these parameters tau 1, alpha 1, beta 1, tau 2, alpha 2, beta 2, such a way, and B, such a way so that these minimum, this gap square, MSE, mean squared error, becomes the lowest. Okay, you choose such a way that becomes the lowest. Okay, so for example, choose only one specific parameter, tau 1. So choose a tau 1 as such a level so that this function becomes minimum. So that is the way to choose these parameters. So now the issue is, if you have more inputs, like not only the profit, not only depends on quantity sale, maybe other factors also part of the issue. Company type, location of the company. So there are many other factors influencing the profit. So in that case, input node can be more, like another input node. Another input node. So there can be more input node. More input node means more hidden layers. More hidden layers, but final layer will be one. Final layer will be one. So input node, input layer can be many, and accordingly, hidden layer can also be many. And that will be more complex to show within this functional format. But I think nowadays computer will be doing that. But when you have more input, that means a similar thing will be more. Just will be added. That's it. That's it. And how these so many parameters are calculated by minimizing this MSE, that is basically searching method, you know, Newton method, Newton search, which first of all, it chooses a specific set of parameters, all parameters, then find out this MSE value. Then if they then show another set of parameters, then check again what is the MSE. By that way, they check which set of parameters is giving the lowest value of MSE. So that way, the searching method is used to make to identify these parameters, and then predicted value of y.